Hello, I'm Channa Bankapur. October LeetCoding challenge is over and I have successfully completed by solving all the daily problems in time and also weekly problems. There are 5 weekly problems. So overall, I have solved 31 plus 5, 36 problems. And not just about solving them, I have made videos of all of them with my solution. So if you haven't solved any of these problems, give it a try and then take a look at my video for my approach. All right. So let's get started with the November Lead Coding Challenge. So as expected, they have released two problems. One is the daily challenge problem and another one is the weekly challenge problem, right? So I'm going to discuss my solutions to both of these problems in this video. So the daily challenge problem is convert binary number in a linked list to integer. So a binary number is given in the form of a linked list where each node represents a bit, starting with the most significant bit. We need to convert this into an integer, right? A regular like int data type or something like that. So how do we solve something like this? So let's see. It's not a very difficult one. Suppose I'm going to take an example which is little more than what we have here. So I'm going to have a bit sequence 1101. So 1101 represents number 13 in decimal. So this is what we need to convert it into, right? So it's in a linked list form and we can start reading from the most significant bit here, right? This is our head. So eventually I need this in a bit string, which is in the form of an integer. So when I say int, it is also a bit string essentially, right? Maybe like 32 bit or something like that. So we are going to have bits here, and so eventually I need to create something like this 1101 here. So how do I do that? I don't know the position of this is actually index 3 if you start with 0. So we don't know this is at index 3 because we don't even know the length. And do we really need to know the length? If we know the length, we can always go and insert there. That's one way of doing it. But another way of doing that is we don't have to do it that way. We can start by looking at these bits. If there is a bit here, start inserting at the head here. But before inserting at the head, whatever we have created, left shift it so that you make place for that. So initially, maybe everything is 0, and what you can do is so you basically make a place for the one for this bit, the bit which is at head, and then insert here. Even though right now I'm inserting at the least significant bit position, LSB position, don't worry about this. Eventually this is going to become most significant bit, right? So when I get the next one, so now I have one here, and when I get the next one, so I'm gonna left shift this one so it becomes 1 0, and then we have a 1 here, so I'm going to insert 1 at this place, resulting in 1 1. So now I have 1 1. Now I get a 0. I'm going to left shift this one to make it 1 1 0, and insert 0. Inserting 0 is not going to be it's not going to change the value, so we have 1 1 0. Now I'm going to get another one here, the last one, which is least significant bit. Now I'm going to left shift this, it becomes 1110, and then there is a 0 here. So insert 1 here, that is as good as adding 1, so it becomes 1011, right? So this is exactly what we are going to do, which is as simple as that, right? So then this is an int data type, so it should hold the number of bits given there, and just return that value. All right. So it's, and let me directly get into the coding. So what we need is the result, which is going to be initialized to 0 here, right? And so we have a linked list here starting with head. If head is already pointing to null, that means we don't have any more bits. So as long as it is not null, I'm going to go inside here. So now because I have a bit, I need to make a place for that at the least significant bit position. So that's why I'm going to left shift the result by 1 bit, right? This is left shifting by 1 bit. And if the value at the head, right, the bit we have right now, if it is 0, we don't have to do anything. This is all we need. If that is 1, then we have to insert that bit at the least significant bit of of result, which is as good as just incrementing by 1, because we know the least significant bit is 0 now, and if you increment, that is going to become 1 and nothing else changes, right? We can do it differently, but yeah, I found just incrementing is very easy. And then obviously head pointer is moving, and when we are done, we have a result, and then we're going to return here, right? So let me run for the custom example we explained with. So 1101 should be, if we run that, yeah, so 13 is the expected answer and we got it right. So let me submit and it should accept it. It is accepted. All right. So if you want to know the time complexity of this is linear to the number of bits we have or the number of nodes in the linked list, right? So that's all. It is not dependent or it is not totally dependent on the value we are going to get. So in this example it was 13. So it is not in terms of 13. It is the number of bits required to represent 13, right? So which is log of the value, right? Or the number of nodes in the linked list. All right. Sure. Let's move on to the next problem, which is weekly challenge problem. It's a premium problem, but it's also not that difficult. So meeting rooms is the title of the problem. We have a bunch of intervals given. Each interval represents a meeting. So now we need to see that if a person can attend all these meetings which are given there, right? So when a person cannot attend is when two meetings overlap. That means there is at least 1 minute of overlap where the person cannot attend. So in this case, let's take this example: 0 to 30 units of time. There's a meeting, and 5 to 10 there is a meeting. Obviously, the first two meetings overlap, so he cannot attend. We don't have to even look at the other meetings. But in the second example, we have 7 to 10 and then 2 to 4. Obviously, 2 to 4 appears before in time, and then 7 to 10. So in this case, yeah, the person can attend all the meetings. So the solution is not that difficult. If you see, if you just go by their starting time order, and whenever you see that whenever a meeting is going on, if another meeting, the next meeting which starts after this starts before the current meeting ends, then as in the person cannot attend the meeting, and otherwise the person can attend the meeting. So that's the simple solution. I don't think we need more explanation for this. So what I have done here is I have taken all the intervals and then sorted them by their starting time. So all I need is starting time. If starting time is equal, I don't really care. I'm just returning false because it doesn't matter, right? Now, what I'm going to do is I'm initializing last end or ending end time of the last interval is 0. We don't have any intervals at the moment. But yeah, as we go with each of these intervals, which are already sorted by their starting time, and see that the starting time of the current meeting is before the ending time of the previous meeting. This is the ending time of the previous meeting, right? In that case, there is an overlap and we are going to return false because the person cannot attend the meeting. Otherwise, yeah, so we'll, because now we need to go to the next meeting. So that means the ending time of the current meeting becomes, ending time of the last meeting. And then that's how we go on to the next one. So if there are no overlaps, we come out of this for loop and then we're going to return true, right? So that's all. And let me submit here and see whether it works. Yeah, it accepts. And again, what is the time complexity of this? So if there are n intervals here, we are going to sort them. So we can use, we can assume that this can be done in big O of n log n time. So if this is already big O of n log n time, and we have another loop here, but another loop is actually just linear time here, right? Linear time, and within the loop, it's all constant time operations. So that's why the overall time complexity is the significant part is actually sorting here. So I'm going to take big O of n log n, right? And I don't think this can be solved with lesser than big O of n log n time in the worst case, right? Yeah, if you have some other method where average case is better, that could be different, but worst case, I don't think it can be improved. If you think it can be done in linear time in the worst case, let me know in the comments. Or if you have any comments on either of these solutions, both of these solutions we have discussed, let me know. And yeah, please like the videos and subscribe to the channels. So here there is our channel here, GoMaster Coding Interviews. Please subscribe to it and like the current video, and also go through the videos of these October LeetCoding Challenge. And I have started like about 7-8 days in before October, so that's why there are about 8 videos in September LeetCoding Challenge. Also take a look at that, right? Otherwise, there are other playlists. If you're interested, you can always take a look. All right. Yep. Thanks for watching. Happy coding.